Okay, so this is the continuation of this problem. So we made it up to this point. We know what is the work for the process 1, 2, 20.95. And now we need to find what is U1 and U2. So in order to find first U1, again, we need to go to table A5. Table A5. And the same as we did for the volume, at P equal 150 kilopascals. Let's look at it on the table. Let me zoom in. Okay, so 150 kilopascals, which is right over here. We have UF equal to 466.97 and UG equal to 2519.2. So let's see, we have UF equal to 466.97 and UG equal to 2519.2. Okay? So again, these are the values that correspond to this one and this point over here. Okay? Fluid, saturation, gas. Alright, so now we can find U1 as being equals to UF plus X1 UF minus UG. Okay, so if you do this calculation, you find that U1 will be equal to 877.416 kilojoules per kilogram. Let me zoom out a little bit. Sorry for that. There we go. Okay, so let's go back to this figure over here. Now you see at 2, this is still a mixture. So we can maybe find out what would be the quality at 0.2. Okay? So in order to find the quality, we can use the expression. So let us find quality x2 first before finding u2. So we can use the equation because we know what V2 is, will be equal to V fluid plus X2 V gas minus V fluid. Okay? And we know V fluid and V gas from the page number 1, which is 0.001053, and Vg is 1.1594 from table A5 again. So that if we do that calculation, so over here we know V2, so we have X2 will be equal to what? V2 minus V fluid divided by Vg minus V fluid. Okay? And the value for V2, we have it from page number 2, is equal to 0.3724. So if we do the calculation, what do we have? 0.3724 minus 0.001053 divided by 1.1594 minus 0.001053. And this gives us 0.3206, which means that the quality factor X2 would be 32.06%. Now that we know the quality factor, we can do just like we did right here. We can find that U2 will be equal to UF plus X2 UF minus UG. And if you do this calculation, you find that U2 will be equal to 1124.88 kilojoules per kilogram. Okay, so finally, if we recall that equation over here from page number 3, we have Q12 over M will be equal to U2 minus U1 plus work 12 over M. So this will be equal, so if we do this numerical application, we find that Q12 over M is equal to 268.415 kilojoules per kilogram. Okay. Alright, so we found everything between 1 and 2. Let's see if I find that page again. So we did everything between 1 and 2. We know what is the work. We know what is the heat. Now let's see what happened between 2 and 3. So process 2, 3. So just by looking at the figure, what's important about this process is that we see right away that it's constant volume. So that's really good because actually it's going to simplify a little bit the work, because if you remember by definition, the work is P dV, or with a minor manipulation, which is knowing that specific volume equal volume over mass. We did it before. The work per unit mass is equal to P dV. So if V is constant, that will mean that dV is 0. So basically that means that work 2/3 over M, which would be this one over here, is 0. Okay? And using again the first principle of thermodynamics, we have Q23 minus work 2/3 will be equal to M U3 minus U2. But we just show over here that this will be 0. So basically at the end we have that Q23 is equal over M, is equal to U3 minus U2. So we know the value for U2, we need to find U3. Okay? So how do we find U3? So that's going to be a little bit more complicated. Let's go here to the table. So we know basically that U3 is saturated vapor. So we know the state, okay? And we know that V2 is equal to 3. So about state 3, what do we know? We know it's saturated vapor. Okay, and we know V3 is equal to V2, which is equal to, let me see if I can find it in one of the previous pages, 0.3724. Okay, but because it's on the saturation line, this is basically Vg. Okay, so now we can go to table A5, and we can look at where would be the value 0.3724 on the table for the Vg's values. So that's what I do over here. So I go, let me see if I can zoom in a little bit. I think that should be good enough. Let's see. All right, so the Vg values, let's go up, is this column over here. So now we need to look for 0.3724. And that's not going to happen up to the bottom here where we have the pressure 500 kilopascals and 550. So for one, the value is 0.37483, and for the next one is 0.34261. All right, so from table A5, we have at P equals 500, we see that, let's see again, Vg is equal to 0.37483, and we can say also Ug will be equal to, so here, 560.7. Now we do the same thing at 550. This would be Vg is 0.34261, and Ug is equal to 2,563.9. Okay, so now we need to go and do the interpolation. So maybe let me just go to the next page. Okay, this will probably be the last time that I do the interpolation in detail. After that, I'm going to refer you to the video I created just for the interpolation. All right, so over here, what are we trying to find? U3. So if you remember, you need to plot on the y-axis whatever you need to find, and on the x-axis, all the information that you have. So in our case, what do we know over here? So let's see. The lower Vg will be at 550. So if we put here 0.34261, the U value is 2,563.9. So this corresponds to the pressure at 550. Okay? And then at 0.37483, the value of the energy is what? 2,560.9. So basically, the interpolation, we go down, and what we're trying to find is the value at which value here? At V3, which is equal to V2, that we say was equal to 0.3724. And this will correspond here to the value U3. Let me zoom out, sorry for that. Okay. All right, so in order to find this value here, what do? We can start either from here or here. Let's just start from this one. So this will be equal to what? U3 will be equal to 2563.9. Now we'll move down, so minus the slope of this curve, that will be equal to 2563.9 minus 2560.9 or 7. Let's check the table. At 500, the energy to 560.7. This is a 7, sorry. So let me correct this one. This is a 7 over here. Okay, so this is a 7 over here. All right. Divided by 0.37483. So this is the space over here. So 0.37483 minus 0.34261 to find the slope. And now this space over here. So this will be 0.3724 minus 0.34261. And this is going to give us a value for U3 equal to 2560.94 kilojoules per kilogram. So finally, Q23 over M was equal to what? U3 minus U2. So this gives us that Q23 over M is equal to 2560.94 minus the U2 value that we found before was equal to, let's see if I find it, 1124.88, and that gives us a value for Q23 of 1436.06 kilojoules per kilogram. Alright, so to answer the question of the problem, basically they ask us what is the work and the heat transfer for the whole process. So for processes 1, 2 plus 2, 3, what do we have? Work over M equal work 1, 2 over M plus work 2, 3 over M. So this one was 0. So we get that the work for the whole process will be equal to whatever we found for work 1, 2 over 2, and that is equal to, let's see if I can find that information, 20.95 kilojoules per kilogram. And the total heat transfer will be Q over M equal to Q12 over M plus Q 23 over N. So for Q12 we found 268.415 plus Q23 1436.06, which gives a total heat transfer of 1704.47 kilojoules per kilogram. Okay, so I did show all the details for the solution of this problem. That's why I had to split it into different videos. Alright, see you next time.